Yep. Chal, comes on everyone. Hope everyone has gone through the notes, must have done all the problems. Let's start off with the problem. The last class we were started throwing things from the buildings. So consider a particle is projected with speed u vertically, and we have acceleration due to gravity is minus g naught y. So the ground level y is 0. So y is the height of the particle from the ground. Meaning, look at this planet. It's a little weird. Meaning, when y is 0, there is no gravity. As you go up, the gravity is becoming more and more. Getting it? And the minus sign indicates the direction is downward. So the gravity is not constant. And if the gravity is not constant, you can't use your three equations. Remember? So particle is projected vertically. With speed u, right? And the gravity is changing continuously. I think let me write on this again. So a is equal to minus g naught y. G naught is some constant. This would be a proper advanced paragraph level question. Find h max, velocity, find the maximum height, find the velocity as function of time t, or let's say height as function of time t. Find height, find velocity and height at time t. Third, find time of ascent and time of flight. So if I have to ask you this question in advance, I'll ask you find h max and time of flight. That will take care of everything. Let's see how to do this thing. Remember, you can't use your three equations. You have to go back to the basic. What is the basic? Acceleration is dv by dt, or acceleration is v dv by dy. That's your basic. You have to go back to the integrations. Give it a try. So this planet gravity, as you go up, it is increasing. Generally, the gravity would have decreased, but it is a reverse. Willis, can you keep your cam on? How do we approach this? Got an answer? Do type in the chat box to the co-host. Everyone should give it a try. It's okay not to get an answer, but to give it a try. How did you can't use u square by 2g? If anyone is using u square by 2g, don't do that. How do you get a minus sign? Minus sign is simply direction, right? Meaning yeah, Vihan, you got it. You got H max. Root. How did you get a number, re Poroja? Speed u tha. Answer will come in terms of u and g not only. U square. Right, Devansh. We have two answers so far for H max. Keep going. If you got the first part, there are still two more. Those are the more deadly ones. The first part is like, it's a good one. And you got it. We have three answers for the first part. Niharika. Why did you bring GT, Ray? And you meant to say G not kya? U by root G. Why did you get sine function there? Is it a sine? H max का sign नहीं आएगा God. Let's see the first part. So when you're projecting with speed u, so let's just write it down. So what is the acceleration? Acceleration is minus g naught y. Now remember, you can't use the three equations because a is not constant, but you can use the general stuff. What is that? V dv by dy. Now why didn't I use dv by dt? Because you're asking everything in terms of y coordinate. Why will I use time? So there are two forms that you can use, dv by dt or v dv by this thing. So we can put v dy minus g naught y dy. So then you integrate on both sides. If you remember, this is how we derived the general equations also. Integral v dv is equal to g naught is a constant, integral y dy. So when y coordinate is 0, this is the meaning of lower limit. When y is 0, your speed was u. When the height is y, your speed is some speed v random. Integrate this. This is x power n ka integration. U to v minus g naught. This is y square by 2. Limits will be from 0 to y. This thing comes out to be v square minus u square by 2 is equal to minus g naught by 2 y square. 2 cancels off. We get v square is equal to u square minus g naught y square. This is your velocity as function of this. Now this is pure integration. But now how to find h max? Do you guys remember how we derived h max in the regular derivation? Now see, the basic concepts will never change. What happens at h max? At h max, the vertical component of velocity becomes 0. Isn't it? Then we use the standard equation and we kept v is equal to 0. So these things will not change. At h max, your vertical component has to be 0. So if you want to find h max, at h max, or when y is equal to h max, your velocity v is equal to 0. So substitute 0, you end up with u square minus z naught. This is h max square. So from here we get h max is equal to u square u by root g naught. There, that's your first answer. So this is the second result actually, velocity as function of, we want as a function of time, but okay, I think we can get that. But this is a v as a function of y. Please have a look at this. This is your velocity as function of height. So it doesn't look like your regular equation. Your regular equation was v square is equal to u square minus 2g y power 1 tha wo. 2 was missing and this was a square. There, we got the h max. The second part, find the velocity and height at time t. How do you proceed from here? This is a brute force integration. Even though the problem looks like a lot of physics, it's actually more of maths. Try. I'll give you a minute or two. And I'm pretty sure you guys forgot. I'll help you with this. Have a look at this page. This is the hint. Write down this result if you want. This is the second integration that I taught you. The three special integrations is the second form. Answer is height at time t. Yeah. Once we get that, we will get the velocity also at time t. This is the formula we're going to use. Integral dx by a square minus x square is sine inverse x by a. There. Now get back to the question. Try. You got a minute. Find height as a function of time t. If you got that, I think you'll get everything from there. There, I know velocity at y. I need to find time t. So v is equal to. Just let me help you a little. So what is v? dy by dt. So again integration. So dy by root over u square minus g naught y square. Zero to t, 0 to y. There. If you integrate this, you'll get the answer. Ne u by root g sine g naught t. Okay, you found the height as a function of time. That looks right, Harika, then. I'll write down the formula here. So dx by root over a square minus x square is sine inverse x by a. Try. I'll give you a minute. So the both look same, then you have to just modify it a bit and use the formula. Like I told you, whenever these integrations come, I will show you. So don't worry about the part. We are a physics class. When they actually teach you this in max in 12th standard, you will think this is a joke. So the three special forms of integration, do remember that. Adi, clear so far? No answers. Do give it a try. Arnav, clear with this? Taksha? Niharika, find the time of flight also. So, integral dy by, I'll do one thing, take out root g naught common. You end up with u by root g naught whole square minus y square is equal to integral dt. You can clearly see this thing looks like this looks like a and this looks like x. So this formula becomes sine inverse x by a, which is y by a is u by root g naught. Limits will go from 0 to y, and this is root g naught t. Limits will go from 0 to t. So this is sine inverse. Sine inverse 0 is 0. Root g naught y by u is root g naught t. So send sine on the other is the sine inverse. So root g naught by u into y is sine of root g naught t. So therefore we get y coordinate is u by root g naught sine root g naught into t. This is your y coordinate as function of time t. Interestingly, it's a sine function. You want velocity? Differentiate it again. dy by dt, which is u by root g naught. Then you can substitute this thing here. Sine ka differential will be cos root g naught t, and then differentiate whatever is inside. You get root g naught. That cancels off, and you get u cos root g naught t. That's your velocity as function of time. Do have a look at the integration. So the main thing, you need to know the second form of integration, that is sine inverse function. And I need to convert this in the form of a square minus x square. So if you see this x square ka coefficient is 1, but here there's a g naught sitting there. So I just pushed it outside. I didn't do much, it is just max. This would be a proper advanced paragraph level question. For your level, it is tough. When you're in 12th, this would be a moderate question. But advanced, if they decided to harass you, this is the kind of question you'll get. But again, like I said, this is more of a max question than physics. The physics got over. The moment you wrote this thing, physics got over. Question's still not over. We need to find time of ascent and time of flight. How do you proceed from here? Try, you got a minute. You have everything that you need right now. You can find the time of flight and time of ascent. Again, think, how did we find time of flight and how did we find time of ascent? Any doubt so far? Anyone not convinced? Please ask me. Just clear so far? Surya, Vignajit, Navya, clear with this? Please make sure to go through the integrations again. This question, right, after the class gets over, sit, take 5-10 minutes and take a rough paper and try to resolve the whole thing. That way you will remember better. Don't think like, I understood in the class. You did nothing. I did all the work. You just listened to it like a movie. The problem is not yours until you try it on your own again. Pi root g. Pi by root g or pi into root g? Into क्या है? नहीं रे. Check करो, you goofed up somewhere.
Yes, sir. Pi by root g.
What is that? Time of flight, time of ascent?
Time of flight.
ठीक है. So we got the y coordinate is u by root g naught sine root g naught into t. Now, straightforward question ho gaya actually. So when you go up and then you come down, for time of flight, your y is equal to h max. Sorry, time of ascent. So when your y coordinate is equal to h max, you're at the time of ascent. When you reach the ground, time of flight is when your y coordinate becomes 0, isn't it? When you come back to the ground level, what is your y coordinate? 0. So if y is equal to h max, which is u by root g naught, which we derived, this is equal to u by root g naught. This will be sine root g naught time of ascent. So that will cancel off. You end up with sine root g naught time of ascent is equal to 1. So we get root g naught ta. So the sine theta should be pi by 2. So from here we get time of ascent is pi by 2 root g naught. If y is equal to 0, then the time is time of flight. Now here you have to be careful. If you put y 0, you get u by root g naught sine root g naught t 0. Most people think root g naught t can be 0. Agreed. That gives you the initial condition. Or root g naught t can be pi also. Sine 180 is also 0. This 0 ka thing is your initial condition. Because see, you simply told the max, find me the time when you're on the ground. You're on the ground 2 times. At t0, you're on the ground. That I don't want. So we always neglect that. And this thing will be your time of flight, which is pi by root g naught. There, that's how you get this thing. Height at y and h max. Arnav, in the question that you typed, you only will understand. Let's say your height is going like this: 0 meter, 1 meter, 2 meter, 3 meter, 4 meter, 5 meter, and then you come back 4 meter, 3 meter, 2 meter. Is there no difference between what is your maximum height and what is your height at any time? There's a difference, right? What is your height at 1 second is not same as what is your maximum height. Hope that is clear. Please check it out. The one thing you can notice some things, while going up and while coming down, it is the same gravity, meaning they look left and right, they look identical. So you can say time of ascent is equal to time of descent here. And which actually shows time of ascent, time of flight is double. Check it out. This is how questions will be framed in a vertical motion. Throwing from buildings is fine. This is good. Do check it out. Any doubts, please ask me. Clear? Next one. What are the main points? Don't worry about writing the notes. You'll get the PDF. Focus on solving and understanding. No one gets marks for writing beautifully. Next one. Recently, someone was asking, I'll make a beautiful note. I think I told you this. Don't waste your time. You have time, solve more questions. Yeah. Processing is fine. Any doubts? Anyone not confused? Anyone confused with any particular thing? Please ask. Don't hesitate. Get the concepts cleared. But if you frankly think about it, don't see the question and feel like, oh, itna bada hai. It is not that. Actually, try to think, what did you do? This is the physics part. After that, it is just brute force integration. So if you think that way, it won't feel overwhelming. The overwhelming part is trying to understand what is exactly happening. Figuring out is the overwhelming part. You should be happy if these kind of questions come in the exam, because most people will get scared and leave it. And if you don't leave it, that makes you special. And that will put you in the top 4,000 ranks. Next thing. Projectile motion. So with that, we are done with the 1D part. We studied how things go left and right. We studied things go up and down. Now we will combine both of them and we'll start throwing things at angles. So what's a projectile? A particle projected at an angle theta with respect to ground. Where theta is not equal to 90 degrees. Means you don't want to throw it vertically because it will become a 1D motion again. But there's a better definition than this. So if someone asks you, when does a particle go in a projectile motion? A better way to define this is the velocity vector and the acceleration vector are not parallel or anti-parallel. Should not be parallel and anti-parallel. That's it. You can project U with whatever angle you want. Just make sure you're not parallel or anti-parallel. So sometimes they'll ask in the exam like this, like the velocity is this, acceleration is this, in which case the particle goes in projectile motion. Then this definition will make you confused, like, okay, there's no ground here. How do I define this? So having a general definition is helpful. That means if you're projecting like this U bar, you can have acceleration like this A bar. So as long as you don't have theta 0 or 180, it's a projectile motion. Now, how do we study something like this? When things are start going in a curves or something, frankly speaking, we don't know what to do with this. If you throw something at an angle, we don't know how to study. So whenever we get something, unknown, it is always like this in science. You always study unknown with what you know. You try to split the unknown into pieces and try to see what similarities are there, and then you try to make it up. So we do something similar here. So the idea here is we study this by resolving the motion along two perpendicular directions. Then, so when you divide them into two pieces, these are two one-dimensional motions. Which we know how to study. That's what we did till now. And then whatever results we get independently, vectorially. Let me tell you what it means. This thing, right? There's a name for this. This is also called as principle of superposition. Quite a useful concept. We see this a lot in physics, even in science. What this thing says is if there are two independent events, if event 1 creates an effect 1 and event 2 creates effect 2, then event 1 plus 2 will create effect 1 plus 2. Looks obvious, but it is not true every time. For example, if you have a block M, if I give force F1, acceleration is A1. If I have the same block F and if I give F2 and the acceleration is A2, if I apply F1 plus F2, I will get acceleration A1 plus A2. The best part, this need not be even in the same direction. You can have F2 like this also. Now, if you apply F1 and F2, this guy will go A1 this way and A2 this way. So they will just add it up. This thing works most of the places. Let's say we have a circuit like this. I'm sure you studied in current. Let's say there are two batteries, V2 and V1. So what we do, first remove this battery. Only due to this battery find the currents. Then remove this battery. Only due to this battery find the currents. And then if you add both the currents, you will get the current active when both the batteries exist. So if there are 10 batteries, there's no need to study all 10 batteries at the same time. Study the currents due to one battery and then add all the currents. That will be the current when all batteries are present. So this thing just keeps popping up everywhere. Principle of superposition works when the things are independent. Let's see how to use this for motion. So listen carefully. The next 3-4 pages will be like complete theory of projectile. You got this, your basics are clear. There is no more theory than that. The only thing is then we will do different variations of the problems. This is something I keep telling you in physics. There is nothing called theory as such. The entire chapter can be summarized into 2 pages of, what do you call concepts, formulas, models, results, everything you can finish off in 2 to 3 pages. Most of the chapters. The headache is on the 2 pages, you can create 100 pages of different models. If you see, we have done till now almost 34 questions. I think rarely we repeated anything in that. And we didn't use anything other than the 3 equations. So we have a particle here, x and y axis, and let's say this is projected with speed u at an angle theta. So what we do, we split the motion, the horizontal component, let's call it ux. The u subscript x indicates you're talking in x direction. This is u subscript y, which is u sine theta. So ux, which is u cos theta, this is the horizontal component of initial velocity. u subscript y, which is u sine theta. This is the vertical component of initial velocity. When you're throwing something into the air, the gravity is acting in the vertical direction. So this is your ay, which is minus g, and the horizontal acceleration ax is 0. So basically there is no horizontal acceleration. Later on we will see what happens if there's an horizontal acceleration. But first we will learn the easy stuff and then we'll bump up the level. So we can split this motion into two parts. So where one motion we have uy, which is u sine theta. So this thing will simply go up and go down. So meaning we're assuming if the particle had only vertical motion. So this will take care everything in the y direction. So whatever information you need in y direction, this component will give. Similarly, the horizontal, which is ux, is equal to u cos theta. This will give you all the information in x direction. Remember, there's a gravity here. Remember, there is no acceleration in this case. Now, your three formulas, now since the acceleration is constant, I can use my regular formulas. The three formulas are still valid. So let me write that Sy is uy t plus half ay t square. So S is ut plus half a t square. I'm putting y everywhere to indicate that I'm talking about y direction. So Sy is nothing but the y coordinate. Uy is u sine theta. Half ay is gt square. There, you got the y coordinate as function of time t. Then we have Vy is equal to Uy plus Ayt. Again, Vy is your vertical velocity. Uy is u sine theta. A is minus gt. There, we are still using the same three equations. Nothing changed. So this will give you the y coordinate. This will give you the y component of velocity. Don't worry. In the end, I'll put a full table. We'll have all the results in one page that you can copy it down. That will be good to remember. And what about the same thing for Sx? So for now, just try to absorb everything. Uxt plus half axt square. Again, I'm not showing you anything new. We're not doing anything new here. Sx becomes the x coordinate. Ux becomes u cos theta into time. And remember, the ax is 0. So this term we will not be writing. So this gives you the x coordinate. And this is Vx is equal to ux plus axt. This becomes Vx is equal to u cos theta. That means if you see in this page what we did, at any point of time, I know the x coordinate, I know the y coordinate, means I know the position of the particle. At any point of time, I know the velocity in the I cap direction and j cap direction, I know the velocity. If I know the position of the particle and velocity of the particle, don't I know everything about the particle? If you tell me where is the particle, and if you tell me what is the velocity of the particle, and I know the acceleration, I can find any information that you want regarding the particle. Now, I don't know how to study this, but I know how to study up and down. I know how to study left and right. When I combine these two, which I'll show you in the next page, I'll be able to study curves. Please have a look at this page. Anyone not clear with any particular step, concept, anything you didn't understand, ask me. So the main idea here is whatever happens up and down, the horizontal doesn't care. Whatever happens left and right, the vertical doesn't care. The both are two independent motions. X and Y do not interfere with each other. Clear with this? Turning the page. Any doubts? Next. Now, what we got here. So your u sine theta. So this thing goes up and comes down. Like I keep telling you, I draw it like this because if I draw like this, you won't understand. It actually goes up and comes down along the same line. So I'm just putting a little to the side. And this is your u cos theta, which is going horizontal. So what we will do, let's find the x coordinate and y coordinate at different times. So let's say t1, this is your x coordinate. y coordinate, t2 this is the y coordinate, t3 this is the y coordinate, t4 this is the y coordinate. So meaning 1 second, 2 second, 3 second, 4 second, 5 second, you're finding all y coordinates from here. Same thing, 1 second, 2 second, you're finding all x coordinates from here. And now if you plot them on a graph, so at t1, I know my x and y coordinates. So this is the t1 x coordinate. At t2, see what I do. At t2, this is x. At t2, this is y. So at t2, this is x and this is y. So this point. Are you getting how I'm plotting the graph? So at every point, at every time, I know what is my x and y coordinate. So I'll put all the graphs that t2. This would be t3. Let me draw it a little more tall, actually. This is better. So this is t1. This is t2. This is t3. This is t4. This is t5. And this is t6. Now, if you can take 100 points, I will get more close points, isn't it? And when I join all of them, I'll get a curve. There. We learned how to study a curve from two straight lines. And if you notice something here, this point is your h max. The h max depends only on the y coordinate. And if you notice here, it is the same h max here. So whatever happens in the vertical direction, the u sine theta takes care. So if you go back to the h max formula, if you remember, when I wrote the h max, how did we write? Let me show you how did we write. We wrote it in a very standard format, uy square by 2ay. This is the reason I wrote like this that time. We never wrote directly u square by 2g. So the formula is u vertical square by 2a vertical. So here uy is u sine theta. So it will be u square sine square theta by 2g. That's your h max. What about time of flight? 2uy by ay, which is 2u sine theta by g. Time of ascent. So everything you learned in the vertical motion is valid here, which is u sine theta by g. Time of descent will be same as time of ascent, u sine theta by g. Now, whatever you learned there is valid here also. So these two things which we get are valid only if you come back to the same level. Let me tell you what I mean by that. Comes to same level of projection. That means if you're going to throw from buildings, the particle has to come back to the same level. So if you throw from buildings like this, or if you throw from buildings like this is not valid. Don't use these formulas. We have to do it in a different way. If you throw from buildings, you can't use this time of flight and time of descent. So time of flight and time of descent are not valid. So be very careful. I have seen common mistake. They ask time of flight and they use the formula to use sine theta by g. Blunder. Remembering formulas is good, but you should remember when to use, when not to use. If you blindly remember, then it actually becomes you'll mess up unnecessary. Have a look at this page. There we found everything about time of flight, H max, we got all the stuff. Nothing new, right? Only thing, wherever there is u, you replace with u sine theta. That's what I'm saying. Try to think that way. Don't think like ये सब नया formulas है. That will overwhelm you. You're learning nothing new. The only thing you learned new is that you can split a motion in horizontal and vertical, and they don't depend on each other. That's it. That in the page. Any doubts on this page? Ansh, Devansh, Niharika, clear? Chinil, Nikhil, Ojas, going ahead. Next thing, range. Now, when you throw this with u and theta, so this thing goes and falls somewhere here. This is something new, range. So how do you define range? Range is simply the horizontal distance traveled in time of flight. Now, how do we get this? When you say horizontal, means everything in the horizontal equation. So uxt plus half axt square. So if you put t is equal to time of flight, this guy becomes range, and this becomes u cos theta into time of flight, and that term is 0 because ax is 0. I'm specifically writing ax is 0. We will see later on ax won't be 0, and then all these formulas will go for a toss. That is the range part, and the time of flight is given to u sine theta by g. So you can write this thing as u square 2 sine theta cos theta by g, and we know that is that becomes u square sine 2 theta by g. So this is a formula for range, u square sine 2 theta by g. Again, remember, this is valid only if you come to the same level. Obviously, because the time of flight ka formula is not valid if you throw from buildings. Meaning, again, same thing. If you start throwing from buildings, this formula will not work. How to do that? That we will see. This or these cases is not valid. Don't use this range ka formula when you throw from buildings. When I say buildings, heights, mountains, anything from an altitude. And if you notice something here, theta in 90 minus theta gives same range because it is sine 2 theta. It will become sine 180 minus 2 theta. Sine 180 minus 2 theta is same. They give same range. And theta is equal to 45 gives maximum range. Again, when you throw from ground to ground, the meaning of this is let's say you throw with some speed u at 30 degrees. You go and land here. If you throw something with the same speed u but 60 degrees, so which is 60 and 30 are 90 minus theta, it goes higher, but it comes and lands again at the same spot. So you get the same range for these two. So this gives you everything in the horizontal direction. Have a look at this page. All clear with this? Look at this. This is this Colorado thing. I'll send you this thing after the class. You guys can play with this, but I'm sure you must have played better games. There's a game called Pocket Tanks. Ever saw that game? You have a small tank, you have to put an angle and fire. So this thing, right, you can actually adjust everything. So let's put it at the ground level, right? And there you can change the angle like this by moving it up and down. So if I put something like it's a 70 and 15 meters per second and fire, oh shit, right? I got the target at first time. There, you can, so 70, it hit the target. So what is the other angle? 90 minus theta. That means for 20, also I should be able to hit the target. and make sure the speed is same. Oh shit, this is not going below 20. I can't change it. It's not going 20, so it should miss. Yeah, expected. So let's see the other one. So let's say 25. So the other angle should be 90 minus 25. That should be 65. Same speed, we fire, goes up, and lands. There. This is what I was saying. And if you put at 45, that should give you the maximum range. Getting it? You can change everything. You can even put a human, and we can increase the speed, and we can fire. The person is flying. He went too fast. Decrease the speed and fire. Shit, he died. Let's increase the speed a bit there. He's standing, right? I think you can throw even piano is also there. You can throw pianos. What else is there? There's a car. There are a lot of new updated features though. Shit, we have a car. Perfect. So there, you can throw everything, and you can even increase the height, and you can fire. So there, you can play this game like this. And the best thing about this, you can put components, vectors, and now if you fire, you can clearly see how the velocity directions change. Let's slow it down a bit. You guys should definitely check this out. There, as it is fired, you can see how the velocity vectors change. Let me put it back on the ground level. There, see, now if I fire, you can see the velocity vectors. You can observe clearly the horizontal velocity u cos theta, the green arrow, horizontal one will always remain same c. But if you look at the vertical arrow, the vertical component vy, that is changing. It becomes small, it becomes 0, and then it becomes negative. This green spot you can see on the top here is your Hmax. There. So that's your velocity vector. And the best thing, you can even put resistance in this. Now, if you put air resistance, we will see how to do that also later on. And if I fire, as expected, we should get a lesser range. Let's see, are we getting lesser range? It does. There. If you have air resistance, things get messed up. There is a range is decreasing. It's a good simulation. You can try this with velocities and all. And there is one more simulation. It's a similar one, but this thing you can't change much of a data. You can just put one, and you can put a continuous and fire. This thing starts firing. And there's a graph on the top. You'll get all data points. So this is a variable. It is actually more of a probability thing. Anyway, so that's the Colorado thing. The University of Colorado has done this. I'll send you this after the class so you can check it out. Now, getting back to this, there's a game called Pocket Tanks. I used to play a lot in IIT with that. So you get a tank, your friend gets a tank. So there is a big hill and all there. So you're with a tank here and you're with a tank here. You have to shoot him. Both of you have 10 projectiles. So it's all ranges. You can increase the speed of the projectile, you can change the angle, you can fire, you have different weird bombs. It was a fun game. And now that we have PUBG and all big games, but during that time, that was a big thing for us. Next one, the equation of trajectory. So equation of trajectory is simply the equation of the path. So when you're firing with u and theta, so during this motion at any instant, if you take any particular x coordinate and y coordinate, assuming we are starting from origin, so I want to find the relation between x and y coordinates. So we know the x coordinate is given by u cos theta t. So from here, I'll get time t is equal to x by u cos theta. And we know the y coordinate is given by u sine theta t minus half gt square. So take time here and substitute, you end up with u sine theta. T will be x by u cos theta minus half g x square by u square cos square theta. So we get x tan theta minus gx square by 2u square cos square theta. You can also write this thing. If you take out x tan theta common, this thing turns out to be 1 minus x by r. You get it in a more simpler form. You can verify that if you want, where r is the range. So these are the two forms of trajectory which you should remember. And if you look at the equation, it's an x square quadratic equation. This is a parabola. That means the curves which you're seeing are parabolas. Have a look at this. So this is your equation of trajectory. When someone says the equation of trajectory, it is simply asking you a relation between the x and y coordinate. Any doubts on this page? All clear with this? Ojas, Ignajit, Purvaja, Vihan, clear so far? Abhinav, Adi, Ahana, clear? Devansh, Navya? Going ahead. Arnav, clear? Next thing, velocity and acceleration profile. Hence, how does velocity and acceleration change with time? So when you're firing like this, look at this thing. The horizontal component, u cos theta. Now, since there is no horizontal acceleration, no matter how much you travel, the horizontal component never changes. Whereas if you look at the vertical component, initially it is u sine theta. As you go up, the arrow becomes smaller because the velocity is decreasing. It's u sine theta minus gt. At the highest point, the vertical component becomes zero. But this is one important thing. What is the speed at highest point? People say zero. Be careful. It is not zero. The vertical component is zero. At the highest point, there's still a speed u cos theta. And then it starts coming down. And when you reach the ground back, you come back with u sine theta. So at any instant, if you look at this, this is how your velocity is going v at an angle alpha. So your velocity is continuously changing its direction. So if you look at here, the speed v bar is nothing but the horizontal component vx I cap plus vy j cap. So this is given by u cos theta I cap plus u sine theta minus gt j cap. This is your velocity vector. And if you look at here, v is the, and from here we can get tan alpha is nothing but the vertical component of velocity by horizontal component of velocity, opposite by adjacent side. This is u sine theta minus gt by u cos theta, where alpha is the angle made by the velocity vector. V bar is a velocity at some time t with the horizontal. And you'll also notice horizontal velocity is always constant. So this gives you one of the very important result. That means the horizontal component u cos theta. And if you look at in terms of v and alpha, it is v cos alpha, isn't it? The horizontal component here is v cos alpha. So they both should be always equal. And at h max, vy is 0 and the speed is and velocity is u cos theta. It is not, total velocity is not 0. Horizontal. And if you look at the gravity, gravity is always down. No matter where you are, gravity is always pulling you down. So acceleration is constant. So there. So these are the main points here. The four important points in this. The velocity vector. Actually, literally everything is important in this. U cos theta is V cos alpha. Tan alpha is this. At h max, the velocity is u I cap. Do have a look at this page. Any doubts on this thing? Let me put all the formulas in the next page. All clear with the velocity and acceleration profile. Next thing. So when you project with the u and theta, let's say at any particular position here, this is your r bar. R bar is your position vector, x comma y. This is your velocity vector, v bar. The position vector is given by x I cap plus y j cap. That's what you learned in vectors. But here x is u cos theta t I cap. This is the first thing that we did in projectile. And the y coordinate is u sine theta time minus half gt square. This will give you the coordinates. Velocity v bar is vx I cap, vy j cap. This thing I just now wrote it. U cos theta I cap plus u sine theta minus gt j cap. Tan alpha is v vertical by v horizontal, which is u sine theta minus gt minus by u cos theta, where v is the angle made by this. So this is alpha. And then we have y is equal to x tan theta minus gx square by 2u square cos square theta. Or you can also write this thing as x tan theta into 1 minus x by r. And then we have your standard stuff. H max is u square sine square theta by 2g. Range is u square sine 2 theta by g. Time of flight is 2u sine theta by g. And u cos theta is equal to v cos alpha. What more? Yeah, that looks everything. Time of ascent is equal to time of descent is equal to u sine theta by g. Remember, this is not valid if you throw from buildings. Yeah, all this much stuff is there. You can note it down. This is the entire concept of projectile. You can throw from buildings, you can throw from anywhere. These things will always work. Which ones will work? These ones will always work. That's the reason I wrote, this H max and all, I wrote it in the end because those are not general equations. Those are very special cases when you throw from ground to ground and when AX is 0. But do have a look at this. You can note it down, put them down. Maybe writing them down, you'll remember or nothing else. You can put it down. We're going to do problems based on that. Put it on. I'll just get some water and come. Done? Let's see a question. Arrange the page. Let's see this question. This will take care of all the formulas. So we have a particle projected with 20 meters per second. This is 60 degrees. Gravity G is 10 meter per second square. First one is the standard stuff. Find H max, range, time of flight. The second one, find the speed and the time at half of H max. So when you reach the half of the maximum height, what is the speed and the time? Find speed and height at 1/4 of the time of flight. Find the time when velocity vector v bar makes an angle 45 degrees. Basically, that is alpha. With horizontal. Find the time when the r bar, the position vector, is perpendicular to the velocity vector. Find d mod r bar by dt. Hope you remember what is d mod r by dt. We discussed about this extensively at H max. It is not dr by dt, it is d mod r by dt ka differential. Let's get all the 6 questions. First one is easy. Give me answers from the second one. In this thing, if you ask me, the B is a good one, E is a good one, F is a good one. These are the main ones if you ask me. But F would be an advanced one. E also a good question. B is also fine. Remaining are fine. Let's try. We get this question. This will take care of all the formulas that I did so far. Let's start. 1 minute for the first one. Just need to put in the formulas. Yeah. Get the second one. Anyone confused with the question? Anything you didn't understand, please ask. If you didn't understand the question, it is my fault. Don't know how to do, that's totally fine. Give it a try. I'll be showing you in some time. Let's see the first one. Okay. H max is u square sine square theta by 2g. U is 20, so that's 400. Sine 60 is root 3 by 2 ka square, so that's 3 by 4, and 2g is 20. 20, that is 105, 15 meters. So range is u square sine 2 theta by g. U square is again 20 square. G is 10, and sine 2 theta is sine 120, which is again root 3 by 2. So 120 will cancel. That's 20 root 3. And the time of flight is 2u sine theta by g. There should be no doubts here. There's nothing here. 2 into 20, 40 by 10 for 2 root 3 seconds. I'm more interested in B part ka speed. Speed is not 20, Abhinav. That you goofed up. Try. I'll give you a minute for the B part. Speed and time when you reach half of the maximum height. And this is not new, huh? We have done something like this. If you remember in 1D, this was the first question. Find time and speed when it is H max vector. You don't get partial marks, Abhinav. Get the both. Time तो लग रहा है, right? I don't know. I don't remember the answers. But I think it looks wrong, रे. इतना अच्छा आंसर नहीं आएगा. I hope you just didn't do half of this. No, na? Niharika, you got it. Arya, you are wrong. Speed wrong है वो. Niharika, I think you got the speed part right. That much I remember. Jainil, nah, that is wrong. Let's look at the data. Ishana, what is that? Time, speed. Both are wrong. It doesn't matter. Take it out. Let's look at the data. What did I give you? I said that I find the time when the particle is half of h max. That means indirectly you are telling me the y coordinate is 15 by 2 meters. Agreed? Now you need to go back to the formulas and remember which equation has y ka thing. So the equation is sy. You're talking about vertical direction. See, it is a simple idea. You're talking about vertical direction. You have only three equations. V is u plus at. I can't use this y. Isme v hai. V square minus u square is 2s. I can't use this y. There is a v there. There's only one equation left, s. So sy is uyt plus half ayt square. You just need to check what do I have and which equation fits. So sy is your y coordinate 15 by 2. Uy is u sine theta, which is 20 sine 60 time ay is g half 10t square. That is 2553 by 2. That is 4 2 root 3t minus t square. We get a quadratic. T square minus 2 root 3t, numbers are bad, plus 3 by 2 equal to 0. We have t is equal to 2 root 3 plus or minus d square. That is 12 minus 4, 3 minus 6 by 2. So we have root 3 plus or minus root 6 by 2 is root 3 by 2. Check. And why did we get two answers? Why did we get two answers? Because you simply asked the mathematics, give me the time when you reach half of h max. You didn't tell it when. So Max gave you all the possible answers. If this was h max, there are two instants when you reach half of the maximum height. One while going up, one while going down. We encountered the same thing in 1D also. And we can clearly see here, you reach up first. So this should be the shorter time, which is root 3 minus root 3 by 2. This should be the longer time, which is root 3 plus root 3 by 2. So maybe you didn't realize, but mathematics remembers and it gives you both the answers. So you're going to reach half of the maximum height 2 times, one while going up and one while coming down. So please check where you guys messed up. There is nothing there other than realizing that we have to use the vertical equation y, and the second equation s is ut plus half at square. Again, this is what I'm saying. You are not learning anything new in projectile. So don't think like it's a new one. Always think like this is something which I know, plus there's a thoda variation hai. If you think like that, you'll be able to connect stuff. You'll start finding things interesting and it'll become more easy. But if you think every concept is different, it'll overwhelm you. Question is still not over. We have to find the speed. If you got the speed, please go ahead with the other questions. How do we find the speed? Now, the mistake most of you guys are doing with the speed. Any doubts on this page, please ask me. Great. So if you want the speed part, this is the mistake. Generally, everyone forgets this. V bar is Vx square plus Vy square j cap. So when you want speed, mod V is root over Vx square plus Vy square. So there is a horizontal component also. But luckily, Vx is constant, which is u cos theta. U is 20, and this guy is cos 60, which is half. So this is 10. What about Vy then? Now we can use Vy square minus Uy square is 2Ay Sy. Your three kinematics equations are still valid. So Vy square, and what is Uy square? U sine theta. So that is 20 sine 60. I'm going to write it down directly. That is 10 root 3 ka square. And remember, up is positive, down is negative. So gravity is minus 10 and the displacement is 15 by 2. So from here I get Vy square is 300 minus that guy is 150. So this is 150. So therefore your speed will be root over 10 square, that is 100 plus 150, that's 250, that is 5 root 10 meters per second. Projectile motion with this headache is there. If I ask you for speed, you have to find Vx and Vy and then square them and add them. You didn't have this problem in 1D motion. You would have got the answer directly. So I think someone did get 150, but you forgot Vx then. Please check it out. This is how you find the speed. Niharika, you got the same, no? No. You got the same. Yeah. Did the same? Niharika, you did the same thing? Okay, good. Please check it out, anyone. The B part is a pretty good question. And we just use the three equations, nothing much. Any doubts? The speed and the time. Go ahead with other questions. Get the C part. Find the speed and height at 1/4 of time of flight. Any doubts on the B part? Please ask me. It's clear. Go ahead with the C part. C is easy. D is direct formula. What if I have 4? Let's see. The C part, again, like I keep saying, always get the data first. You gave me the time of flight is TF4. So once you see the data, right, and what you have, that will actually start giving you ideas like, okay, what do I have and what do I need? Time of flight is 2 root 3 ka 4. So that's root 3 by 2. Again, number looks bad. You're asking for speed. That is fine. Vx is 10, that doesn't change. So Vy is Uy. Since now there is a time, I'll use the first equation. So Vy, Uy is U sine 30, that is 10 root 3 minus 10 root 3 by 2. So this is 5 root 3. The speed is root over Vx square plus Vy square. That's root 175, 5 root 7. Check out your calculations. Yep. What about the height? The second equation, y is equal to u sine theta t minus half gt square. Like I said, simple substitution. U sine theta is 10 root 3 and time is root 3 by 2 minus half 10 t square is 3 by 4, and this guy would be 30 by 2, 15. 15 minus 30 by 2, 15 by 4. That is 45 by 4 meters. Yeah, check out the steps. This was easy. Right, Purvaja, you got it. Ishana, you got it. Niharika, you got the speed part. D is straightforward. You're asking the angle, so there's only one formula. Tan alpha is u sine theta minus gt by u cos theta. But the issue here is you said find the time when it makes 45 degree. But you didn't tell me which 45. You could have made 45 while going up. You could have made 45 while coming down. So we have to take both the possibilities. Alpha is plus or minus 45. So this is plus or minus 45. U sine theta is 10 root 3. This is 10t by this is 10. 10 will cancel. This is plus or minus 1 is root 3 minus t. There we get two roots. This was an easy one. So this is root 3 minus 1 and this is root 3 plus 1. That's your D part. C and D are direct formula based. Any doubt from this page? Let's see the question. Let's try end F. Find the time when R bar is perpendicular to V bar. R bar is your position vector, V bar is your velocity vector. Just to give an idea what is happening, think of like this. When you're going like this, there is a particular, this is your R bar, this is your V bar, and I'm saying these two are 90 degrees. At what time does that happen? Try. Like I said, this is like this problem will cover all your basics, some decent problems also there. Next class, we'll do some pretty deadly ones. I mean, good ones. Let's try this. Try. You got 2 minutes for the E part. Give it a try. Then maybe after a minute, I'll tell you something. Maybe I'll give you a small hint. Then I'll give you 1 more minute. Think about it, Vignachit. Now, I told you this multiple times. When you're doing questions, right, just don't think like I'll solve the question, I'll get the answer done. Once the question gets over, sit for a minute and ask yourself, in this question, what made me think I should do like this? In the beginning, it might feel like a little time consuming, but if you do that for a day, nothing happens. You do it for a month, nothing happens. When you do it for 6 7 months, suddenly things will change. You'll start developing a kind of an insight. You see a question and you know what is happening and why it is happening. If you don't develop that kind of insight, you will struggle with the questions. And one of the reasons why people, if you see in top 5,000 ranks, you ask them what is your favorite subject, at least 4,500 people will say physics. Without physics, you're not going to enter the top 5,000. You need to ask yourself what made me think like this. Like example, I told you this multiple times. The moment you hear the word two vectors are perpendicular, what is the first thing that should strike your head? Dot product is zero. That's it. Meaning the moment you see the word two vectors are perpendicular, the first thing that should come to your mind is there are two vectors and the dot product is zero. So indirectly is asking me to do the dot product. That's the first thought that you should have got it. You'll get a cubic, but उसमें एक t common आ जाएगा रे पूर्वजा. सब में t है. Remove that t, you'll get a quadratic. We will not take t is equal to zero root because at t is equal to zero, r bar is a zero vector, which is undefined direction. So we don't take t zero ka root. Right, Niharika. Ishana, you got it wrong. Daksha, what did you do? You did something totally alien. Someone is missing in the class today. Daksha is missing. Yep, I was thinking. You're right, Niharika. Then you go for the F part. You have a very interesting answer. Let me show you. The interesting answer is there is no answer. Look at this. So you project with u and theta. So basically, you're saying there will be a particular point where this is r bar and this is your v bar, and you want them to be perpendicular. Perfect. What is your position vector r bar? U cos theta t I cap. This is what I said. You should literally know what is r bar and v bar without hesitation. If you get stuck here, you will get stuck with all the tough part of the question. Basic should be pretty clear. Half gt square j cap. So if you substitute the values here, u cos theta is 10. So this is 10 t I cap. U sin theta is 10 root 3. Half g is 5 t square j cap. If you look at the velocity v bar, this is u cos theta I cap plus u sin theta minus gt j cap. U cos theta is again 10 I cap plus this guy is 10 root 3 minus 10 t j cap. Since r bar is perpendicular to v bar, this implies the dot product r bar dot v bar is 0. You know how to do the dot product? Multiply the I components, 10t and 10. 10t square is 100t square plus 10 root 3t minus 5t square. 10 root 3 minus 10t. Shit, these numbers are bad. This would be 100t square plus 10 root 3, 10 root 3. That would be 300t. And 10 root 3, 10, 100 root 3t square. This is 50 root 3 t square and 50 t cube. If you remove t common from all of them, you end up with 50 t square. This is 53t Yeah, I cooked up somewhere. F is 10, no, right? This thing. This is not a t square, this is t actually.
Plus will be minus 100 root 3 t square.
Which will be
minus 100 root 3.
minus 100 root 3, no?
Total will be minus 150.
You're right. 150 root 3 t plus ये 400 होगा. You can remove that 50 also here. You will get t square minus 3 root 3 t plus 8 is equal to 0. You'll end up with a quadratic. We don't take t is equal to 0. That is your initial condition. Now, if for this, if you find the discriminant b square minus 4ac, that turns out to be 27 minus 32, which is minus 5 is less than 0. There are no real roots. Means roots are imaginary. I told you this multiple times. If you got imaginary, what is the meaning of this? The meaning of this is the situation which you asked. So what did you ask? Find the time when both are perpendicular. And the max is saying, I don't have a single time when what you're asking will happen. So the answer for this thing is, it never happens. So R bar can never be perpendicular to V bar. That's the thing. And t is equal to 0, we don't consider. That is because at t 0, R bar will be a 0 vector, and 0 vector is all directions. So it's an undefined. T bar 0 is not considered. Since R bar is a 0 vector. So for the E part, there is no answer. At least in this question, it is not possible. Maybe if you change the angle and the speeds, now it would be possible. But this given data, the question, it is not making sense. If you see, this question is actually easy but lengthy to solve. Don't get confused between a tough question and a lengthy question. An easy question can be lengthy. This is lengthy. This is easy, but you just need to do dot product. Tough question would be something like F. And again, in case you forgot what is F, but any doubts on E part, please ask me. E part is just brute force dot product. There's nothing I did. And for dr by dt, in case you forgot, let me show you that theory. You can have a look at this page. What is dr by dt? Dr by dt is radial velocity. D mod r by dt is the rate of change of length of the vector. Don't use this u cos theta, Purvaja. This u cos theta is different from that u cos theta. This is the velocity in the direction of r bar. It's called radial velocity. So I'm asking this d mod r by dt at the h max. Think, take a minute or two. It's a good one. They never asked anything like this, like the F part. It's not standard. You won't see that F part in mains or bits. It's not 10. Let's see. Let's try to understand the meaning of this. So this is the thing. Now at the highest point, your velocity is u cos theta. That is fine. Now at the highest point, this is your r bar. Agreed? And let this angle be some beta, which I don't know yet. Now if you look at the components, this guy would be, if you look at the components of this thing, this is r bar. So if you look at the components now, this would be u cos theta ka adjacent component, which is cos beta. This would be u cos theta ka opposite component sin beta. Now you tell me, what is d mod r by dt? The velocity which is responsible for changing the length of the vector. Now can you tell me between these two components, who is helping you to change the length of the vector? The cos theta cos beta, isn't it? Isn't that how we defined a radial velocity? The component of velocity. So d mod r by dt ka meaning is component of velocity along r bar. Now more about this you can study here. I will put the reference. Page 35. We extensively discussed about this. So in this case, so d mod r by dt. So if you know the concept, it is straightforward answer. U cos theta, which I know, cos beta, I need to find beta now. That is easy. So from here, if you drop a perpendicular, so in this triangle, this point is h max, this angle is beta, and this is half of the range. So from here, we get tan beta is h max, the opposite side, by r by 2 is the range. So this guy is u square sine square theta by 2g. This is u square sine 2 theta by 2g. U square will cancel, gg will cancel. You end up with tan theta, that is sine theta by 2 cos theta. So tan theta by 2. There, you got beta ka value from here. So you can substitute there and you're done. You'll get the answer. Theta ka value is given. So how much is that? Tan beta, tan theta is tan 60. So that is root 3 by 2. I told you how to get cos from tan. If this is beta, opposite side is root 3, adjacent side is 2. Hypotenuse will be 3 plus 4, root 7. So cos beta is 2 by root 7. So u cos theta is 10 and this is 2 by root 7. So the answer is 20 by root 7 meters per second. So this question is tough because figuring out this part is the tougher part. Solving is easy. This is a question which is tough but easy to solve. You should know that concept d mod r by dt means what. Another way to do is find r bar, find mod r bar, then differentiate and then put time in that. That would be a mess, but you would get the same answer. Please have a look at this. Clear? So there. That's the last one for the day. Now we will discuss the last week ka paper, exam ka paper. Even though it looks like we did two questions, we did some two pretty big ones, like that initial one and this thing. So do make sure to try the whole thing again. It looks like you understood, but trust me, you take a rough paper tomorrow, sit with the question without seeing the solution, try to do it on your own. You will get stuck. That is fine. Struggle for 2-3 minutes. Then just look at the part where you got stuck and then again try to do. If you don't do that, you will not remember. So especially revise this question, what we did right now, because next class we will be doing more varieties. And then I will expect like you remember what is R bar, what is V bar, meaning it is like basic. That much you should know. So based on that, we'll be developing more higher level problems. Okay, so that is there. So any doubts in today's class, first you can ask. Then we'll discuss the paper cut doubts. If you have no